We heard now about the LoRa modulation. And people sometimes mix LoRa and LoRaWAN. LoRa is the modulation, as we saw, like SSB, like CWs, like FM, whatever. LoRa is just a physical modulation. And LoRaWAN is, as it says, wide area network, is a network which uses this modulation. So these is one level higher in a way in the networking protocol, at least. So much better with the missing link. Okay, LoRaWAN is a star network. It's not a mesh or anything else. It's a star network, and it consists of different sensors, many sensors. It consists of a few gateways. Here is 868 megahertz in between, so it's air. And these gateways are connected to the internet, and they go into a server network. And if you want to have the data from your sensor here, you connect to this service, and your application then gets the data. And the relationship between the two is just a number. Each of these sensors have a particular number, and if you use this number to retrieve the data, you get the data of your particular sensor. And of course, you get only the data of the sensors you registered. So there is some encryption in between and so on. Now, we see it has 1, 2, 3, 4 parts. This part is usually with us because we are interested in the results. This one is usually with us because we place the sensors. And this here is sometimes with us and sometimes not. And this is also sometimes with us or not. And I show you now who does such network providing. The first one was the Things network. This was when LoRaWAN started 6-7 years ago. They are in Amsterdam. And these were a bunch of young guys, and they founded this Things network, and everybody who wanted was able to build a gateway. I have here, this is a gateway. You can give it away around, and the other one, I show you afterwards another one. And so we built them ourselves and mounted it on our roofs and so on. So everybody had his own gateway. But now in Zurich, for example, if you have 4 or 5 gateways, you don't need a gateway. You just switch on your sensor and you will get the data. Then the next one was they have to make some money. So they used what they built here, all the software, and they sell it to companies with an additional service contract and so on. So this is open, this is closed, but it's more or less the same functionality, the same software behind. Usually they develop here, they try it with us, we are the guinea pigs, and then they roll it out here. Then also Swisscom was one of the first national carriers. You have a Swisscom network in Switzerland, which where you should be able to switch on the sensor wherever you are, and it should connect to the Swisscom network. But of course, this is paid and not easy to get to if you are an individual. And the third one is, there is a chirp stack. You can also use their software. This is the whole software needed to run this network, this LoRaWAN network. And you can use here containers on a Raspberry Pi or whatever. Now in modern gateways, sometimes the whole chirp stack runs on the gateway itself because these are Linux systems and so on. If you start, you will see later on, I would strongly suggest to start here. and maybe you go in this direction. Most of the people never end here. And if you have a cat, for example, you will go with Swisscom because the tracker for your cat is licensed and runs on the Swisscom network, for example. Now the performance is something important. Is this the new Wi-Fi? No, it is not. Matthias mentioned something about the spreading factors. So spreading factor 7 is the fastest, spreading factor 12 is the slowest. Unfortunately, the wrong way around. And, but the range is the best with 12 and the worst with 7. So you decide basically which spreading factor your sensor uses. A gateway can listen to all spreading factors. If you build just a mesh ASTIC, for example, as we will see later on, these cheap chips, they can only decode one spreading factor at one time. So you have to decide there. With LoRaWAN, you decide each sensor can be different, no problem. The range, I wrote here, the sky is the limit. In reality, it's line of sight, more or less. If you have line of sight, it works. If you do not have line of sight, it works not, unless you prove it. This is just a very good line of sight, a very good rule of thumb. And the sky is, there are many LoRa satellites around now. I have a base station at home, a receiver, and it has just a quarter wave ground plane, nothing special. And I get LoRa messages from over 2,000 kilometers. And you can imagine the satellites are quite low on the orbit at 2,000 kilometers. So I have a lot of atmosphere in between. So if it's line of sight, it works. I had also, for my 60th birthday, I presented myself a world record on the Earth, basically. This is now 7 years ago, if you want to know how old I am. And this was 203 kilometers. The problem was not LoRa. The problem was that I didn't find a line of sight which was much longer here around my home. Okay, the speed, SF12 is like Morse, maybe a reasonable operator. But it's this speed, which is no problem for sensors, which is not for even audio or video. It is an LoRa protocol, very important. It's just doing LoRa, and everybody who hears it has the message, but the sensor does not care. There is no feedback channel in LoRaWAN. Very important. You can send 6, 7, 8 or a little bit more messages every day. So it's really not made for a back channel. It's the up channel. It's sensors. And if you do not get the temperature this time, you get it next time. So that is the principle. So I would not do financial transactions with it, probably. And the LoRa principle is from Hawaii. It was there invented. That's why it's called LoRa protocol. And very important, the protocol via air is very densely packed. So no IP, no whatever. You even pack your binary data together, that you have a very short message. Because the longer the message, the more energy you need, and the more airtime you need. And for all these ISM bands, there is one thing, duty cycle is less than 1%. So your sensor must not transmit more than 1% of the time. Don't ask me how it is calculated. I calculate it every day. Others say every hour, but every day is better for me because when I switch off the sensor, then I usually achieve it in 24 hours. So that is very, very important that you respect this, because others otherwise will not work on the same channel. We have 8 channels in Europe for LoRa for LoRaWAN. They are all the same. And as I mentioned, it's mostly upload. So how should you start if you don't, if you have nothing with LoRa? The first thing is the sensors are low power, really low power. They should work for years as a typical range. So we do not talk about microamperes. We talk about in the range of nanoamperes in between the messages. Because if you transmit the messages, it's 100 milliampere. And an SF12 message is easily 1.5 seconds. So you can imagine how much is left for the 24 hours in between. So that is very important. If you want to tinker with LoRaWAN, you need to understand low power design. Then usually we get modules. I have a few here. We can look at them later on. And usually the standard chips from Semtech are SX12, 76, 78, 62, and so on. These are typical chips there and in the modules. And then we get, even now, we get modules that have LoRa. These are LoRa modules here. And we get also some with LoRaWAN functionality. So you do not need to care about the networking protocol, everything. You just send them an AT message. Please send this message and with this number and so on, and it does everything automatically. Then, if you have a gateway around you, it will work just right out of the box. Your sensor will work. If not, you can buy a ready-made one, or you can use this Raspberry Pi with a hat. There is software, open source software available. The use cases are smart cities, street lighting, waste management, parking sensors. For example, in Lucerne, they have a lot of buses, and they wanted to show the bus drivers when they arrive in Lucerne where to park. So they have everywhere, they have LoRa park sensors. Agriculture, very important, not in Switzerland where we have densely populated, but there are many countries where you want to have the sky is the limit range, because also their ranges are very, very big. Then they also track elephants in Africa, for example, and penguins on the north and the south. Then industrial IT, they do something also. And we have air quality, water level sensors, and so on. And, of course, where I am, my mailbox sensor works on LoRa. Why? Because our mailboxes are proven to be Faraday cages. All the Swiss are Faraday, and it exits this Faraday cage. It exits, it's completely closed, but it works. It's incredible, but it works. So one thing is important. We have a Telegram channel for LoRa in ham radio. So if you photograph this one, you should be automatically connected with this channel. And I hope that we will meet there in the future. Thank you.